right, page 148 in your textbooks. Looking at the review of solving inequalities at the bottom of page 148. Have your binder, your notebooks at the ready there. I'll take a look at the blue problems together very quickly. We've got just a basic inequality here. 2x minus 6 is greater than or equal to negative 4. Very simply, what would I do to solve the inequality, Maddie? To get 2x is greater than or equal to 2, and then of course divide away to get x is good. If we were to graph this, remember, we would put well, how would I graph it, Maddie? A solid dot there at the positive 1, and then we would shade everything to the right-hand side, to the big side, because it says x is greater than. So we've got to shade all the numbers that are greater than 1. Take a look at number 2. We have a negative 4x, negative 7 is less than 9. What would we need to do here, Noah?
You bring this 7 up.
Good. As a
Positive.
To get
16. No. Yeah, no.
well, here I'd get 16. What would I write?
Negative 4x is less than 16.
There we go. And then I would need to
Divide everything by negative 4.
and when I do, I would get
Negative 4.
but I wouldn't just leave that as my answer like I would in an equation, right? Because the sign, the symbol is part of my answer. So how would I write my entire answer?
X is greater than negative 4.
Good. We'd have to flip that around. X is greater than negative 4. And so here, if we were graphing, we'd come down to the negative 4, put an open circle, and shade everything to the positive side or the bigger side. Number 5, what would I need to do first on that left-hand side, Brecken? Brecken, would you please pay attention and listen at the very beginning? Yes, at the bottom of the page, review of solving inequalities. Number 1 and number 2 should look vaguely familiar since they were the ones in the textbook. Number 5, what do I do? To get? Keep going. And then on the right side also. All right, and this actually works out pretty nicely for us, Brecken. We can... yeah, and now what? Good, get rid of the little x so we don't have to worry about that whole change the sign around thing. We won't have a negative this way. What do we have now? Good, and then? To get? Good. If I didn't like the way this looked, if I really, really wanted the x to be on this side, how would I write it? Right, I would just be turning it back around again. And in this case, we would have put an open circle on negative 5 and shaded everything that way. Looking at number 9, what do we call this thing, Maddie? Helper? There's 2 parts to it, like a sentence with 2 parts. Compound inequality, right? So compound just means it's bigger, right? Or like a bone when it's in multiple parts, compound fracture. Did you talk about that in health class yet? Or is that's coming up, that's next quarter. You could talk about all the injuries and diseases and all that kind of stuff. It's great. Anyway, so what do we do here, Maddie? Good, divide everything by that 3. And here, remember, if I were to graph this, I would have both points would have to be marked. The negative 5/3, which again, that'd be negative 1 and 2/3. That'd be right about here, solid dot. And then, of course, the 4, solid dot. Remember, we shade everything in between. We would refer to this type of inequality class as a closed inequality because we have closed dots on the ends. If we look at number 11, 2 is less than 3x and then negative 1 is less than or equal to 5. Noah, what do we do first?
Negative 1.
I'm sorry?
Do something with a negative 1.
Yeah, what do I do to get rid of a negative 1?
Positive.
Positive 1. Where do I put a positive 1?
2.
Everywhere.
Yeah.
Here, here, here. Right? Each of the 3 pieces gets the positive 1 I'm left with.
3 is less than 3x. Less than or equal to 6.
There we go. And then we need to
Divide everything by 3.
divide everything by the 3. And that gives us
1 is less than
And this would be what kind of compound inequality class? Mixed, because we're going to have an open circle at the 1, but a closed dot at the 2, and we're going to shade everything in between. As we look at number 12, we have a negative 4 less than or equal to 5x, positive 1 is less than 11. Brecken, walk us through what do we do? Not or equal to. There we go. There we go. And again, another mixed compound inequality there. If we look at number 13, we're going to break from the blue here. Something unique happens here, Noah. We solve this the same way we would have all the others. We're going to start by just like any equation, Noah, we want to get the x by itself. What's with the x?
-2.
And? What else is with the x?
A negative.
I'm sorry?
-5.
The -5. Which one do we get rid of first?
-2.
Because it's less attached. To get rid of a -2, we put a
Positive.
everywhere. Right? No difference from what we just did on the last couple. That's going to give me
10. -10 is less than -5 is less than 10.
And then, of course, we have to get rid of the -5 by dividing it away. But anytime we divide by a negative, Noah, what do I have to do? Switch this inequality around. So here I get a positive 2, but this becomes a greater than. This just is, this becomes, and this is just -2. However, if I were to look at the number line, I wouldn't put a 2 and then later on put a -2. That's exactly backwards. So remember from past lessons, we have to flip the whole thing around like this. What does it look like when I do?
-2 is less than x is less than 2.
There we go. And so now we have the -2 here, the positive 2 here. And again, the symbols get progressively larger as we work our way across that way. Good. This would be an open compound inequality because we have open circles on both the 2 and -2. As we look at number 15, we have the absolute value on the next page of a third x is less than 2. And we said with absolute value, number 1, class, we always want to isolate the absolute value. Number 2, we want to set the absolute value in an equation equal to positive, negative, whatever. But in an inequality, we don't set it equal to positive, negative, whatever. We either put it between the positive, negative, whatever, or outside the positive, negative, whatever. This is a less than symbol. Maddie, what's the rule for less than in absolute value? Goes inside. So what I suggested was, once this is isolated, and it already is, go ahead and plot the 2 and -2 and show either putting it between or both outside spots. In this case, between. And Maddie, I'm going to turn this into an inequality. How would I write it now? There we go. And from here we just solve for x. And how would I get rid of the fraction here? All right, multiply every piece by 3. There's 3 parts to the inequality. Multiply everything by 3 to get. And there's my solution. Noah, specifically questions on that. Did you pick up on that from the last lesson that you watched? Or were you not able to watch the last lesson? Kind of. Okay. Let's go with number 16. We have the absolute value of 2x is less than 4. Again, we get the absolute value isolated. Okay, we're good to go there. Brecken, now we need to draw a. On the number line, we need to put both 4 and -4. So again, the key with absolute value, positive, negative. The question is, where do I put the 2x? Does it go in between, or does it go in both outside spots? Once again, we have a less than symbol, or less than or equal to would do the same thing. Anytime it's less, it goes in between. So I'm going to turn this thing into a compound inequality, Brecken. And then from here, we're going to divide everything by the 2, and we're going to get, and there's our answer. If we were to look at number 18, we have the absolute value of 3x positive 1 is greater than 11. Once again, the absolute value is isolated. So Maddie, we're ready to draw a. On the number line, we need to put. And we're going to put the 3x plus 1, because it's greater than, Noah, both outside spots. Now you understand this is not going to be a compound inequality, because these two sections of the number line are separate, the one from the other. So it actually becomes two little inequalities. The first inequality, Maddie, we could write. But the other inequality we would write. Good. Or you could say 3x plus 1 is greater than 11, which is usually the way I write it. But if you're just going to write bigger and bigger, that would work just as well. So either this, or this, and that. Regardless, to solve, we're going to have to get rid of the ones class. And that'll give me 3x is less than negative 12. It also gives me that 3x is greater than 10. And of course, we need to divide both sides by 3 to get x is less than negative 4, or divide both sides by 3, x is greater than 10 over 3. And there would be our answer, written as two separate, smaller inequalities. Questions on that, Noah? All right, so let's go ahead and take a look at number 19. We have a 3/2, absolute value of x negative 2 plus 6. And I'm going to change the inequality here on number 19. I'm going to say greater than or equal to 9. Noah, let's take a look at this one together. First, we need to... Good. We are not ready to put our number line. We are not ready to put positive negative 9 on there. It's got to be isolated first, and it ain't isolated yet. Put a negative 6 to get 3. So we have 3/2 times the absolute value of x negative 2 is greater than or equal to 3. But we're still not isolated. We now need to... And what's a quick, easy way to get rid of that whole 3/2 at one time? Right, multiply by the reciprocal 2/3. I'm going to put that 3 over 1. Now, the absolute value is isolated. And here we get a greater than or equal to 2. Now that it's isolated, Noah, now we're going to draw our, right, the number line, which is it's a form of a graph. And on the number line, we're going to put two important points. Good, the positive, negative, whatever. Negative 2, positive 2. Now, the x minus 2 will either go in between as a compound inequality, or it'll go outside as two separate inequalities. Because of a greater than or equal to, I'm going to put it outside both spots. So now I'm going to turn that into two different inequalities. What are my two inequalities? Now this is less than. That direction is getting smaller, right? So x minus 2 is less than negative 2. Or we could say that x minus 2 is greater than 2. You see how to set up the two different inequalities? And then we just need to add the 2's everywhere to get that x is less than 0, or x is greater than 4. And there is my two-part answer. Questions on this? Now that we've gone over it, if you need to go back and rewatch the last lesson, now that you've kind of seen it in person, you may need to go ahead and do that. Turn over to page 456, where your homework was, page 456. And I mentioned before we started recording that the hardest part of the test is probably going to be the Chapter 11 content. Chapter 3, we just had a test over a couple weeks ago. I feel like we got graphing really well. So I don't think that's going to be real hard. We will quickly review some of it. We've kind of been reviewing in the homework a couple of different times. We've seen this. It's been a while since we've done a lot with fractions, hence the homework I gave you last night. Number 1, we were adding fractions in class. In order to add fractions, you have to have a... Thank you, Brecken, a common denominator. And right now they don't have the same denominator, do they? But it said anytime you have a polynomial denominator, you need to do one of two things to the denominator class. Either Factor or group. And in this case, obviously it's going to have to be group. So as we look at this, the common denominator that goes under my big long line, that's key. Adding or subtracting fractions, big long line. Well, everybody needs to be represented. So what goes under the big long line, Maddie? And then what we're going to do is we're going to look at what we had and say, well, from here to here, what changed, Noah? Hey, where'd that come from? Multiply it. Ah, there it is. But what we do to the bottom, class? Do to the top as well. Noah, what do I copy above the big long line?
3x plus 5.
And then here, what changed, Brecken? Yeah, where'd that come from? Okay, put it in there. And what you do to the bottom, class? Gotta do to the top. Or if you want to sound more Matthew, what thou doest to the denominator, thou must also doest to the numerator. But anyway, what do we copy above the big long line, Brecken? And then we need to simplify before we're all done here. What does this all simplify out to, Noah?
8x plus 14.
All over.
X plus 11, x plus 3.
Good. And remember the denominator, I said leave it in the factored form, especially because you might look at this and say, can I factor it? And I actually can. I can pull out a 2, which wouldn't cancel with anything. And it would leave me with a 4x plus 7, which wouldn't cancel with anything, so it wouldn't help me to cancel anyway, so I ain't gonna do it. There I go, I'm done. But you should check and see, maybe you could reduce. How many had this for number 1? Let's take a look at number 5. We have a, complex fraction. And we need to remember, first of all, class, that a complex fraction is simply a division problem. It's just a big, elaborate division problem. But I need to have one thing being divided by one thing. And I ain't got that right now. So my suggestion, there's 2 ways to do it, but my suggestion is this. Turn the entire numerator into one thing. Turn the entire denominator into one thing. What would be the denominator in the top here, Brecken? 2x. Now, Brecken, I ain't got a 2x right now, so I need to multiply it by 2x. And therefore, I also need to multiply this by 2x. What do I put above my big long line, Brecken? But here I've already got a 2x. I don't need to change anything, so I'm just going to write -1. Down in the denominator, what do I put in the bottom for my common denominator, Noah?
X squared.
X squared. But I ain't got an x squared.
Multiply.
And if I do it to the bottom,
To the top.
so up here I need to write,
4x squared.
but this is already x squared. I don't need to change nothing, so
-1.
now I've got one fraction divided by one fraction. But then we have to remember, Maddie, I never really even divide fractions. So I'm going to rewrite this now as a multiplication problem. Maddie, how should I write it? And as I get ready to do this multiplication problem, I see polynomials. Anytime I see polynomials, class, I need to do one of 2 things. Factor or group. Can I factor this, class? And I just group it. Can I factor this, class?
No. Well, yes.
Yes. What is this thing, anybody? Difference of squares factors into a sum and difference. 2x positive 1, 2x negative 1. All right. Now I look for stuff that cancels. And there's actually a couple things we can cancel here, Brecken. This x cancels with one of these x's to leave me with just a single x. So I need to specify x can't be 0 because I canceled it. What else? 2x negative 1. So I need to specify that 2x negative 1 can't be 0. Or better yet, move the 1 over and divide away the 2 to say that x cannot equal 1/2. So that's going to be included as part of my answer. And whatever's left is the rest of my answer. What is left for my answer in the top, class?
X.
Just an x. And in the bottom?
2 times 2x plus 1.
Remember that with a division problem, you have to ask yourself, is there something that was a denominator that moved up to the numerator and did not cancel away? Well, you could say this x didn't cancel away, but there was another x that did. So I've already said x can't be 0, but I should account for it. And there we go. There's our answer. How many at least have the x over 2 times 2x plus 1? Who? Questions? Does it make sense now? We just needed the refresher. We're going to be able to do this tomorrow. All right. Let's take a look at number 13 now. Just a fraction, a single fraction. It says to reduce. And in order to reduce, we need to remember, class, we only ever cancel factors. We never cancel terms. So in order to reduce, I've got to first factor. What factors in the numerator, Maddie? The 15. And when I pull out the 15, what does it leave me with? But I'm not done. I can still factor some more in the numerator, Maddie. All right, what about in the denominator? How would I factor that, Noah?
12.
Pull out a 12. And that gives you
2x squared plus x negative 3.
But that trinomial, that quadratic trinomial, looks like I can keep factoring. Maybe using backwards FOIL, perhaps. I could try to split it into 2 binomials. The 2x squared, perhaps, would split into x and 2x. The negative tells me signs would have to be negative and positive. And the only real way to split up 3. Check the outer inner. Does it give me a positive 1x? It's at like a 5 or something, right? Okay, that's the wrong number. So if the number's wrong, switch the numbers. Yeah, if the number's wrong, switch the numbers. So instead of 3 and 1, maybe 1 and 3. All right, now check the outer inner. Does it give me a positive 1x? There it is. Okay, so now that it's factored, now, Brecken, we get to the fun part, which is to cancel. And obviously we can cancel the x minus 1s, but that's not all. What else can we cancel? Anyone? How about a 3 out of the 12 and 15 to get 5 and 4? So that our final answer is 5 times x positive 1 over 4 times 2x positive 3, where x, class, cannot equal x minus 1 can't be 0, x cannot be 1. And that should have been our answer for number 13. Did we get that by any chance? All right, does it make sense now? Do we remember now how to do this? All right, let's take a look at number 15 then, or excuse me, number 14. Once again, to reduce, class, we have to factor. In the numerator, what do we factor on 14, Bracken? Pull out a 2, more than just a 2. Yeah, let's pull out a 2x, and what does that leave us with? That looks like I could factor further, a backwards FOIL here to get. And the outer inner does indeed check. Down here, Maddie, factor out to leave ourselves with. There we go. And of course, that'll factor further into. And of course, we can cancel away, Noah, the 2 with the 4 to get a 2 and a 1, and the x and the x squared to give ourselves x and then nothing up there. And then we can also cancel the x plus 1s. So our answer comes out to what here, Noah?
1 over 2x.
Careful.
X plus 3.
Right, the x plus 3 is left. Now, if that had canceled, you're right, we would have put a 1. We don't ever leave the numerator empty. And in the denominator,
2x times x negative 1.
where we do need to specify, x cannot be
Negative 1.
negative 1. If it weren't that there was still an x here, I also would say x can't be 0. It wouldn't be wrong to say I did cancel an x, so I could certainly say x can't be 0, but I do still have just a plain old x down here. Don't have to specify it. And then we get this answer on number 14. We get this answer on 14. Questions on this?